All right. So hopefully you've already done this first one. Build the expression, and then let's use legal simplification moves to determine which expression is greater. So for this one on the right one I think is the easier one to do. I can take these two out, and then I can take all four of those out. So what am I left with on this side? 0. Over here, let's see, I can take these two out, and I can take all 6 of these out. And then I need to flip this one over when I move it to the opposite region. I think I've done everything I can do, so I'm left with -3. So which one is greater? The right is greater. Let's do this one without building it. Is that okay? So this is going to be x plus 1, and we're taking the opposite of this, so that'll be -1 plus 2x. Then grouping the like terms, this gives me 3x. And then here, this is going to be 3, oh, excuse me, I'll go ahead and combine like terms there. That's 2 plus x minus x plus 4. This side is going to be 6. Do you know which side is going to be greater? It depends on how big x is. That's exactly right. If x is 1, which side is bigger? The 6 is bigger. If x is 3, which one is bigger? The left side, the 3x. What would make them equal? X is 2. If x was 2, the two sides would be equal to each other, right? All right. So the answer is here is it cannot be determined. We just have no way of knowing. So let's dive into that a little bit more. If the number 5 is compared with the number 7, it's pretty clear that 7 is bigger. However, if you want to compare x with 7, x could be bigger, smaller, or equal to 7. So if we look at this one, if the left expression is less than the right expression, what does that tell you about x? Well, x is less than 5, right? Right, for this one, if the left expression is greater than the right expression, what does that tell you about the value of x? X is greater than 5. What if the two are equal to each other? X has got to be equal to 5 in order for those to be equal. I think that's a relatively easy idea, right? So, for now, to learn more about x, assume that the left expression and the right expression are equal. The two expressions will be brought together on one mat to create an expression mat. If you'll all turn your mats over to the blue side, that's called an equation map. The double line in the middle, think of it as a really long, tilted up and down equal sign. Okay, that's why they did it that way. It's to remind you that those two sides are supposed to be equal. So I'm going to give you a moment. Please go ahead and build this on your mat. I'll give you a minute or so to do that, and then we'll simplify it together. remember that on your paper, the colored in ones are positive, the empty ones are negative. Everybody good? All right, so let's start removing things. There are lots of things that we can remove. I would start by removing, I guess I would probably remove these two first. That's not the only way to start, but we can do that. Bless you. And then I can also remove two of these negative tiles in the negative region and two of these positive unit tiles in the negative region. That just leaves me with one X to flip up. Now, I can't quite do as easy a comparison as I did before, because this one has a unit tile on this side in addition to having an X. I'd like to just have a unit tile over there. I mean, just have an X over there, not have a unit tile. So what I'm going to do is this. You know how we removed these two? Right? We can do the opposite of that. We can add tiles. I'm going to add a unit tile on this side and a unit tile on this side. Why do you think I want to do that?
So you can get rid of, like, you can sell those two, get rid of those.
Right, we can get rid of these now because that's a zero pair. So now I've got 2x compared to 1, 2, 3, 4, 5, 6. Well, if 2x is equal to 6, how much does x have to be? It's got to be 3. All right, let's see if we can do this without having to do it on the mat. So we've got 2x minus 5 is equal to negative 1 plus 5x plus 2. Let's see what we can do with that. Before we do anything else, we always want to simplify. Can we simplify either side of this equation? What can we do, Sammy? Except it's a negative 1. It's going to be 1, exactly. So this would be 2x minus 5 is equal to 5x plus 1. Notice that I have 5 x tiles on one side and 2 x tiles on the other, so I can remove 2 x tiles from both sides, right? So I'm going to remove 2 x tiles from both sides. And then just like we did in the problem a moment ago, we'd like to get rid of this 1 unit tile. It's a positive 1 unit tile. So I'm going to add a negative unit tile to both sides. So I've got negative 6 is equal to 3x. What does x have to be equal to? It's got to be negative 2. Because if I divide both sides of this by 3, I get negative 2 is equal to x. All right, let's see if we can do all of these without having to build everything. I like the building. I think it's a good thing to start with, but it takes too long. I mean, just honestly. So if we start off with this equation, we'd like to get rid of, can I simplify either side? Always start by simplifying. Can we simplify? Yes or no? I need it from everybody. Can we simplify this? Simplify either side. Not simplify the whole thing, but can I simplify like 3x minus 7? Can I make that any simpler? No. Can I make 2 any simpler? No. All right, so I'd like to get rid of these negative 7 unit tiles. So I'm going to add 7 unit tiles to both sides. So now I've got 3x, bless you, is equal to 9. Divide that into 3 equal parts, and then x has got to be equal to 3. All right, let's go on. For this one, can I simplify either side? Yeah. Fact is, we can simplify both sides. Over here, I'm going to have 1 plus x. And over here, I'm going to have 2x minus 5. I always start with whatever the biggest thing is in terms of x, right? Instead of the numbers. I do the x's first. So I'm going to remove an x tile from both sides. I have 1 is equal to x minus 5. So again, I have this same situation that comes up over and over again. I've got these 5 negative tiles on the right side. How do I get rid of those so that I just have an x tile? Yeah, add 5 unit tiles to both sides. And I get x is 6. This one is slightly harder because I have a negative 2x and a positive 2x. But it's the same idea. How about we do that later? I appreciate it though. So I've got these negative 2x tiles. I'd like to have nothing but positive x tiles. I don't know about you, but I'm better with positive numbers than I am with negative numbers. So I'm going to add 2x tiles to both sides. Then I've got these 5 negative unit tiles on the right. How do I get rid of them? Add 5. So if 4x is equal to 8, what times 4 gives me 8? 2. Or you can think about it as dividing both sides by 4. Each x must be 2. All right, let's simplify this one. The right side, nothing we can do with that. But the left side, we can simplify that. That'd be 3 plus 2x minus x minus 1. is equal to 3x minus 6. I'll group the like terms. 2x minus x is x. 3 minus 1 is 2. I can remove an x tile from both sides. That's going to give me 2 is equal to 2x minus 6. I want to get rid of these 6 negative tiles, so what do I need to do? Add 6 positive tiles to zero that out. Dividing both sides by 2, we get that x is equal to 4. All right, for E, let's simplify this. I want the opposite of all of that. So I'm going to actually simplify it first, because what is the x minus x going to be?
Nothing.
Yeah, it's just 0. So this is just negative 3. Always simplify before you try moving things around or adding additional tiles. So how do I get rid of these 7 negative tiles? Add how many? Add 7. And then I would be able to remove 3 negatives and 3 positives, leaving me with 4 positives. Keeping you up? So we get that x is equal to 2. One more. So combine the like terms over here, and I've got 2x minus 2 is equal to 2x plus 1. I'll remove the 2x tiles from both sides, and I have negative 2 is equal to 1. Is that true? That's very much false. There is no solution for this. No matter what you make x equal to, those two sides will never be equal. Any questions?